So in this video, we're just looking at the convergence or divergence of a couple of series. So the first one here, we have 3 to the k minus 1 over 7 to the k. And what I'm going to do before I go very far with this one is rewrite it with using properties of exponents. So I could rewrite this as 3 to the k times 3 to the minus 1 over 7 to the k. And that 3 to the minus 1, I'm going to go ahead and pull that out of the series. So 3 to the minus 1, it doesn't depend on k. And what's in there, 3 to the k over 7 to the k, I'm going to write those to the same exponent. Now these are going from 2 to infinity. And notice what I have here. I have a geometric series with a common ratio less than 1. So this is going to be a convergent series. Now, so this we know is convergent. We're even going to find what it converges to. So we have 3 to the negative 1, which is 1/3. And remember, for geometric series, it's the first term over 1 minus the common ratio. Now the first term is 3/7 to the second, because we were told to start our series, at 2, not 1. So be careful about where you start when you're doing a sum of a geometric series. So we have 1/3. This is going to be 9 over 49. So 9 over 49. This will be 7/7 minus 3/7 is 4/7, but we're flipping and multiplying by 7 over 4. We're going to be able to do a little bit of canceling here. So that's going to go to 1, that's going to go to 7. And so we can say that this and we can do a little bit more, That goes to 3. This converges to 3 over 28. So not only can we say it converges, since it was geometric, we can very quickly say what it converges to. Let's look at our second one. Our second one's a little tricky at first. We have 1 over k to the k. So there's not a real direct root to this one, but here's what I notice. We're looking at k values. We're looking at k greater than or equal to 2. And we know k is greater than or equal to 2 for k greater than or equal to 2. It seems a little redundant, but this is the part I want to work with. This is the part that it's going to be true for. Well, if that's the case, then 1 over k is less than or equal to 1 over 2 for k greater than or equal to 2. So I just flipped both of these, which makes me flip my inequality. Well, then 1 over k to the k is less than or equal to 1/2 to the k. And one thing we can do is rewrite this. The summation is k equals 2 to infinity of 1 over k to the k. Now, what do we know about the series from k equals 2 to infinity of 1/2 to the k? This is a geometric series with a common ratio of less than 1. So we know this converges because it's geometric. We could find what it converges to, but that's not important for what we're doing right now. So that means with what we did right here, this is very important, this guy converges by the comparison test because we showed it was less than something that we knew to be convergent.